All right, so 5.7 inverse trig functions. Let's look at start with the inverse sine. Oh,
And just for my own sanity, we have skipped ahead a couple of subjects, right?
5.5 and 5.6 were graphing. So yeah, I just told you guys to go in there and use a graphing tool to match up the graphs that they ask you about and look at the transitions. And if you have any questions, feel free to ask. But I wasn't going to spend a lot of class time on graphing. I just wanted you guys to get familiar with the actual graphs of the trig functions. So yeah, I didn't spend lecture time on those. All right. So the first function we'll look at is inverse sine. So it's denoted sine inverse of x. We look at this right here, having your -1 raised to or superscript. So y equals sine inverse of x means that if I were to apply the sine to both sides, in other words, let's say if I was trying to solve for x, I would apply sine to both sides. That means sine of y is equal to x. So notice domain and range. Y would be in between -pi/2 and pi/2. X would be in between -1 and +1. So that's going to matter when we look at what we can actually find the sine inverse of versus what we cannot find the sine inverse of. So when we look at sine inverse, first thing we look at is the domain. What am I applying the sine inverse to? If it's not in between -1 and 1, then I wouldn't be able to find the sine inverse of it. All right, so You can start that over, make more room. All right, so you want to find the exact values of sine inverse x. First, you want to let theta be equal to sine inverse of x. Then you're going to rewrite it as if you're solving for x. So remember, this is what I was mentioning before. So if I were to apply sine to both sides, you know, that sine and sine inverse will cancel basically, leave me with sine theta equal to x. So that's what we're talking about here when you say rewrite theta equal to sine inverse of x as sine theta equal to x. And so what's going to be key is that theta, the theta that we are referring to, is going to be in between. For sine, it's going to be in between negative pi over 2 and pi over 2 inclusive. So in other words, if I were to look at my chart, unit circle, pi over 2 is up here, negative pi over 2 is down here. So we're talking about my options coming from these two quadrants, quadrant 1 and quadrant 4. And that goes back to the domain and range of sine. And then they gave you a chart. They gave you the exact value chart to use in order to be able to find theta, find sine theta. All right. So let's try it out. So it wants to find the exact value of sine inverse of square root of 2 over 2. So first thing they tell us to do is let theta be equal to sine inverse square root of 2 over 2. Remember, inverse functions just undo what the original function did. So we're trying to undo what sine did or would do to square root of 2 over 2. All right. So then we're going to rewrite it as sine theta equal to square root of 2 over 2. And if we're just going to use the chart, when sine theta is equal to square root of 2 over 2, the result is pi over 4. And that's the answer. So basically, you could have written this as so, once you get, if you do decide to get comfortable with the unit circle, you could, commit these memory and the relationship to memory, or you would remember that, square root of 2 over 2 in reference to sine would have been pi over 4 and stuff like that. Remember, your options are only coming from your first and fourth quadrants. So you'd ask, what options do you have from the first and fourth quadrants that will give you a positive square root of 2 over 2? And so it would have been pi over 4. But if not, once again, you have this chart, at your disposal. So let's do at least another one before we look at another function. All right. So looking at sine inverse of -1/2. So even if you don't write out these steps, this is how you should be processing the situation. First thing you do is let it equal, or let theta be equal to what you're dealing with. Then you rewrite it as sine theta of -1/2. Then you go to your chart. -1/2 is right here. So that means theta is equal to pi over 6. Oh, I think it was negative pi over 6, right? Yep, negative pi over 6. All right. Questions before we look at cosine? Each one of them will have the same process. It's just that the domain and range will be different. So your options, as far as your quadrants that you'll be pulling your problems from, or you're pulling your answers from, will be different. So in this one, our two quadrants was quadrant 1 and quadrant 4. So is that theta or sine theta is equal to negative pi over 6? That is, so remember what we were trying to find. We were trying to find sine inverse of -1/2. So sine inverse of -1/2 is equal to negative pi over 6. So you're using theta and everything as the part of the process to help, to actually, compartmentalize and set up the process and help you with your steps. Theta is not a part of the original problem. Theta is something you introduce into the problem to help you get to the answer. So good question. So theta is not, you're not solving for theta or anything like that. Theta is something you introduce to the relationship or introduce to the problem to help you find the solution, which is negative pi over 6. So really, the only answer, or the only thing that you really would have, let's say, if without any of the steps, in the way you would have sine inverse of -1/2 is equal to negative pi over 6. So that would be actually the problem and then the answer to your problem. All right. Any other questions before we look at cosine? All right, so let's do cosine. I don't know why I started that like that. Let me put it over to the side. If you already wrote it, I'm not gonna write anything different. I'm just making room. I don't even know why I started it way over there. All right. So here for our inverse cosine, notice our range is going from 0 to pi. Domain is from -1 to 1 for our inverse cosine. And they give us this chart. All right. So those are our exact values for cosine. Notice in cosine, we're looking at quadrant 1 and quadrant 2, going from 0 to pi. So notice theta goes from 0 to pi. All right. So we'll look at the exact value of cosine inverse of -√3/2. So the first thing we do, set it up this way. And we look at it this way, cosine theta is equal to -√3/2. Step 3, we look at our table. -√3/2, 5 power over 4, or 6. Yeah, I said 4, meant 6. And keep in mind that these steps that we're using only work for when we have these exact values that I was talking about before in the unit circle. So we'll talk about other situations and scenarios before we leave this section. But yep. All right. So let's do tangent, and then we'll look at when we don't have exact values. So whether it's sine, cosine, or tangent, it's the same process. Just have to make sure you either have the relationships committed to memory, through the unit circle, or you have that table. Not as means. All right, so that's your inverse tangent function. Notice that it's not or equal to down here. So that's why pi over 2, negative and positive, are not included. But as far as the quadrants we're dealing with, it is the same as sine, in which we're looking at negative first and fourth quadrant. It's just that negative pi over 2 and positive pi over 2 are not included. All right, so let's look at find the exact value of tan inverse of square root of 3. Once again, we'll follow the same process. Let theta be equal to tan inverse square root of 3. Tan theta is equal to square root of 3. Go to the table for the third step. Square root of 3 is right here, and that is power 3. All right. right, questions? Any questions before we move forward?
Nothing here.
All right, sounds good. Sounds good. Next few examples, it says use a calculator to find a value to 4 decimal places. So make sure you know how to use your calculator. They give it like 2 questions on that just to make sure you know how to use your calculator. So yeah, make sure you know how to use your calculator. If you have any problems with it, make sure you get in contact with me so I can help you to do that. But then it gets into inverse properties. All right, so for your inverse properties, I'm gonna do one for sine, cosine, and tan. But just looking at sine before I scroll up too far, notice what changes is the positioning of the application of sine, application to x. Which one is applied to x first? So in the first one, sine inverse is applied to x first, then sine is applied. So whenever you have that scenario, the sine and sine inverse will cancel out and leave you with just x, as long as x is in between -1 and 1 inclusive. Now, if you were to flip the order and let the regular sine be applied to x first, and then sine inverse is applied to what is to the result, then x will be the result as long as x was in between -pi/2 and pi/2 inclusive. So basically it flips, between the domain and range depending on which one was applied to x first. And the same thing happens with cosine and tangent. So basically the sine and the sine inverse will cancel out and leave you with just x under these conditions. So like I mentioned, same thing happens with sine and cosine. Same thing happens with cosine. Cosine of cosine inverse of x will result in just x as long as x is in between -1 and 1 inclusive. Same thing happens when you flip them as long as x is between 0 and pi inclusive. Oh yeah, that's for every real number. All right, so tan applied to tan, or tan inverse of tan inverse of x will result in just x for every real number. So there's no stipulations of what you can use there. Then you have tan inverse of tan x is equal to x for every x between negative pi over 2 and pi over 2. All right. So let's go ahead and try this out. All right, so we're gonna find the exact value. Okay, hold on 1 second. Hello, hope. Oh, sorry about that. There was a turtle out in the yard and someone got scared. So I'll just leave it at that. Guess they thought that the turtle would jump at them. All right, so here we have cosine of cosine inverse of 0.6. All right, so go back and look at your relationships, especially if you're not familiar with them yet. We're talking about this one right here, cosine of cosine inverse of x, of x. So that means the first thing we need to do is analyze where is x? Is x in between this interval? If x is in that interval, then we're good to go. And so when we look at what we have here, 0.06 is in the interval. I'd say this is in. So since 0.06 is in that interval, that means the answer is 0.6. Cosine and cosine inverse will cancel. All right. All right. So next one, sine inverse of sine of 3 pi over 2. So sine inverse comes first, then sine. So you want to look and see what the stipulations on that one would be. So go to your sine inverse first, and then sine. So I need x to be in between negative pi over 2 and pi over 2. All right. So it may not seem like that is the case at first, but let's make sure we examine what we have here. You know that this is pi over 2. This is negative pi over 2. And our quadrants that we're dealing with is quadrant 1 and quadrant 4. But don't forget, on a positive rotation, negative pi over 2 is 3 pi over 2. I said 3 pi over 2. Yeah. All right, so that means that it is in the rotation, so we're good to go. So we're actually looking at, how can I, yeah, I guess I'll stay blue. Sine inverse of sine of let's see, do I want to write it like that? Let's do it like this. No, let's do it like this. So when I look at sine of 3 pi over 2, ask ourselves what is our coordinate here? Remember that would be 0, negative 1. So the sine of 3 pi over 2 is negative 1. And I'm just showing you background as to how this works. And then your sine inverse of negative 1, if we were to go back to our chart, would give us the negative pi over 2. So if we would have just, so that's how that relationship worked. So once we recognize that this 3 pi over 2 is in our domain, 3 pi over 2 is equal to negative pi over 2. So once we recognize that that was in our domain, then we could have allowed these, I need to make room, allowed those to cancel, and that would have been my answer. So that's just the background as to how that works. When you apply sine to 3 pi over 2, you get negative 1, and sine inverse of negative 1 is a negative pi over 2. So the shortcut is to remember the relationships that were emphasized before we got to these problems. And some of these, if you ever get stuck on them, if you throw them in the calculator, they may give you, you may not get the exact answer, depends on your type of calculator, but you will get an idea of what the answer would be, especially when we look at this next one. cosine of cosine inverse of 1.5. 1.5. I guess I'll go purple. 1.5 is not in that domain. So it's not defined. All right. All right. Questions on those before we mix them up?
Nothing here.
All right. Thank you, sir. All right. So if we mix up the trig functions, in other words, not cosine on cosine or sine, but cosine on tan inverse in this case. So we start off, let all right, so first we're going to start off by letting theta be equal to an angle in the interval of negative pi over 2 to pi over 2, whose tangent is 5 over 12. And don't forget where this negative pi over 2 and pi over 2 are coming from. Go back to your relationships. Talking about right here. So when we let theta be equal to something, it's going to be based on, you know, these domains here. All right. Hold on, let me do one more thing. Yep. All right, so we're gonna let theta be an angle whose tangent is 5 over 12. So we can rewrite this way. So that means tan theta is equal to 5 over 12. And don't forget that means that this is y over x. Y is equal to 5. X is equal to 12. So don't forget, it can either be in the first quadrant or fourth quadrant. So if it's positive, tangent is positive, remember tangent is only positive in the first quadrant or the third quadrant. So it means we have to be in our first quadrant if tangent is positive. This down here is theta. We can find R. So here we're trying to find R, but depending on your setup, you may be trying to find X, you may be trying to find Y. So this is the relationship here, of course, we talked about it before. R is equal to the square root of X squared plus Y squared. Plug in your values to find R. All right. All right, so now we can find cosine. So don't forget what we had. Initially, we had cosine of tan inverse of 5 over 12. We said that tan of 5 over 12 was equal to theta. So that means we have cosine theta. Now if we go to our sketch, we have our theta. Cosine is opposite over hypotenuse. So our opposite is 5. Hypotenuse is 13. And that will be our answer. Oh, you know what? Sine adjacent. That was my fault. No, it should be 12. I said opposite. And I said it to myself. So adjacent, which is the 12, is for cosine. Sorry about that. But yep, 12 over 13. So that's how you would do it. All right, questions before we do another one. All right, so this one we have cotangent of sine inverse of negative 1/3. So we're gonna let theta be equal to sine inverse of negative 1/3. That means sine of theta is equal to negative 1/3. So that's y over r. Don't forget r is always positive, so it means y is the negative 1. Oh, also theta All right. So when we look at our sketch, you know that all of your trig functions are positive in the first quadrant. So that means has to be in your fourth quadrant. And we're talking about negative pi over 2 and pi over 2, or 2 pi over 2. So r is 3, y is negative 1, and we need to figure out what x is. Let's go ahead and plug them in. 3 squared. Go ahead and subtract 1. Take the square root of both sides. X is equal to plus or minus square root of 8. And then when you finish that off, you should have 2 square root of 2. And because we're in quadrant 1, theta is in quadrant 1. X is positive. Any questions before we look to finish it off?
Up at the top, where did the cotangent go?
We're about to come back to cotangent now. So right now, we're just dealing with this piece. And that helps us to establish this.
Okay, thanks. Sorry about that.
Oh, no, you're fine. You're fine. So that helps us to find the x piece because we couldn't find cotangent without the x. So that sine relationship helps us to find x. And so now we're looking at cotangent. -1/3. And we had called that sine inverse. We had called that theta. So now we're looking at our chart and say cotangent of theta, don't forget that is x over y. Tangent is y over x, cotangent is x over y. So that x is 2 square root of 2 over y, which is -1. So it'd be -2 square root of 2. Questions? Any questions? All right, let's try one more. Make sure we're all right. Let's go sine. And guess we'll do 10. All right. So we have sine of tan inverse of 3/4. So we start off by letting what's inside of the parentheses or what's being applied by sine to be equal to theta. Then if you apply tan to both sides, this relationship. Also, don't forget theta is in negative pi over 2, pi over 2. Remember that's set up according to the domain of your inverse function. All right. Set up the diagram. And if tan is positive, remember we only have quadrant. We only have quadrant 1 and 4 to play with. So between those two, tangent is going to be positive in the first quadrant. Also, the relationship for tangent is y over x. So it means y is equal to 3, x is equal to 4. There's 4 down here. Go to the right, 4 up 3. And what we need now is r. All right. Plug those values in. (16 plus 9). End up working out even for us. So r is equal to 5. Once you have your missing piece, now you can go ahead and solve the problem. Now all we're looking for is sine of theta. Sine is y over r, or opposite over adjacent. I mean opposite over hypotenuse. So my y is 3, my r is 5, and that is it. I didn't put theta in here, but yeah. All right, questions on anything I've said, anything that you guys see?
I've got nothing.
All right, sounds good. Take that as a great sign. So try the stuff out. See if you get stuck on anything. I believe I posted the review, the test review, and all that good stuff in this class. Let's see. Pearson. Leave my windows up. Doesn't look like it. Mm-mm-mm-mm-mm. 62. We still have 5-8 to do. But just seeing if I've done what I thought I did. If not, I'll have to do it. Nope, I have not. Okay. All right, so I have to post your test review and all that good stuff like that. So that'll be posted shortly. So make sure you guys, if you're not signed up for my math lab, you're getting in there so we can get stuff accomplished. Because in a few, we'll be out of chapter 5, looking to move towards chapter 6, verifying trig identities, and going from there. So if you don't have any questions, I am good. I'll see you on next class. Hope I see somebody in the chat. Oh, you're welcome. Not a problem at all. So if you're good, I'm good. I'll see you guys next class. Have a good one. Be safe and take care.
Take it easy.
Yep,